In this video, I'll be explaining the question Pongal Bunk by CodeChef, and I'll be doing that by using the Scanline algorithm. So, in this question, we are given a number n, right, which is the size of the array, and all the elements of the array are initialized to 0, and there are q queries, and every queries contain two integers l and r, and for every integer I, that is between l to r, we have to add the value I minus l plus 1 to the array at the ith index. So there is an array of size n, every element is initialized to 0, q queries, each query contains two integers l and r, and we need to add value I minus l plus 1 from l to r, every index from l to r. And here we just need to output the m index of the final array. These are the constants. So as we can see, the constants are high. It's 10 is to power 6, n is 10 is to power 6, and q is 10 is to power 6. So if we do it by the time complexity n into q, it will be 10 is to power 12. So coming to the explanation. So as we can see here, I made the n is equals to 5, and there are three queries, l and r, 1 3 2 4 and 1 5. So let's compute it for every query. So from 1 to 3, that is from here to here, I had to add value I minus l plus 1. So if we can observe here, if I put I is equals to l, I can see that the value will become 1 here, l minus l plus 1, 1, and if I becomes l plus 1, it will be 2 here, and similarly 3, 4, and like this, right? So we have to add the value 1 here, 2 here, 3 here, and that's it. These two will remain same, that is 0 and 0. So, and for the next query, we will be adding the value from 2 to 4, that is from here to here. So we have to add value plus 1 here, plus 2 here, and plus 3 here. So our array will become 1, 2 plus 1 3, 3 plus 2 5, 0 plus 3 3, and 0, right? And for the last query, that is from 1 to 5, we'll be doing 1 plus 1 2, 3 plus 2 5, 5 plus 3 8, 3 plus 4 7, 0 plus 5 5. So this should be our final output. So if we calculate the time complexity, as we can see here, if we take l is equals to 0 and r equals to n minus 1, we can see that we need to traverse the whole array for each query. So the time complexity clearly would be here, n into q, and we have seen the constant. This will surely give us a TLE. So what we need to do here is, I'll be using the Scanline algorithm that I have explained in the previous video. So we'll be maintaining two arrays, that is A and P, okay, of size 5 only, and every element of both of them will be 0. So we'll be using Scanline algorithm, same in A. So what we'll be doing is increasing the value of A of L by 1, alright, and we'll be decreasing the value of A at the position R plus 1 by 1. And what we will be doing in this here is, we'll be adding the value at the position R plus 1, we'll be decrementing its value by R minus L plus 1. So I'll be explaining later why are we doing this. Let's just do a quick dry run of it. So for the first query, I'll be adding the value 1 to the index 1. So it's not a zero based indexing. So 1 2 3 4 and 5. So I'll be adding 1 here, and at 3 I'll be at 4, 3 plus 1, that is 4, I'll be doing decrementing it by 1. Alright, and for this, that is our P array, what we'll do is just decrement the value of it at 3 plus 1 fourth position by r minus l plus 1, that is 3 minus 1 plus 1, that is 0 minus 3 is minus 3. Here it will be 0. So the logic here is we know that we need to add value 1, 2, 3, 4, 5 like that, right? So how can we do this? What we'll do is we'll take the presum twice. Let me show you. Like if I take the presum of this now after the first query, it will be 1, 1, 1, 0 and 0. And if I take again the presum of it, so it will be 1, 2, 3, 3 and 3. So as you can see there, from 1 to 3 we need to add the value 1, 2 and 3, and it's doing exactly that. And for this, that we don't need this, right? This both should be 0, so that's why we are maintaining the p array. So we'll be adding the value minus 3 to it. At last, when we'll be doing the presum, we'll be adding the value minus 3 to it, so it will become 0, and after taking presum this will also become 0. So let's do it for all the queries. So the second query is from 2 to 4, so adding the value 1, 2 at position second and decrementing at position 5. Here I'll be decrementing the value r minus l plus 1, that is 4 minus 2 plus 1, that is 3, right? So at fifth index I'll be subtracting the value minus 3. And for the third query I'll be adding 1 here. This will remain same, and r plus 1 doesn't exist, so we don't need to do anything for that. Here also r plus 1 doesn't exist, so array will remain same. Okay, now what we need to do is, as I told you, we need to take the presum twice. So first we will take the presum of this is the a array, right? So after taking the presum, it will be 2, 3, 3, 2 and 1. This will be our modified a array. And then what we'll do is we'll find the presum of p. Alright, and presum of p would be, how we'll find it? It will be pi will it plus equals to pi minus 1, that is its previous element, plus ai. So that's how we are gonna take the presum of p. So let's do it. So here 0 is there, 0 plus of ai, this doesn't exist, so 2 plus 0 it will be 2. Now when we come here at this index, it will be p minus 1, that is 2 plus ai, that is 3. So 2 plus 3 is 5. For this index is gonna be 0 plus equals to pi minus 1, that is 3, plus pi minus 1 is 5 plus ai, that is 3 here. So 5 plus 3, 8. Okay, now for this index it's minus 3 plus equals to 8, so minus 3 plus 8 and then plus ai, that is plus 2, so it will be 7. And similarly for this, minus 3 plus 7 minus 1, it will be 5. So as you can see, it's not clear here, but as you can see, it's similar, it's same as our output. So how we are doing it? Actually we have taken the presum first here. Alright, when we were taking the presum of a, the first presum we took here, and the second presum we took at this p, like, because we were adding the previous value, right, and also adding this. So this was the explanation of the problem. So now I'll do the implementation. So I've already written the code and I've tested it, so I'm just gonna explain it to you. So I've declared a variable n and q, take the input of that, declare two arrays, initialize it to 0. For every query, taken two input l and r, right? This minus I have done because it was on zero based indexing, and just as same as the scanline algorithm, I am increasing the value at L and decreasing the value at R plus 1, and also updating the P here, like I have shown you, right? P at R plus 1 should be minus equals to R minus 1 plus 1. So, and after that, the first presum we are taking here, right? AI plus equals to AI minus 1 from I1 to N, and for the second presum we are taking here at P. And while taking the presum of P, we are also adding the value of AI, and this is just giving the output of the cause. At the last, the question is asking to print the element at the M index, right? What is the question? So yeah, after performing Q queries, a number M is given. It is followed by M number of indices. You have to output the value of the element present in the I index, right? So that's what we did here. We outputted the mth index element. So that's all for this video. Thank you.